Hello students, welcome to Science Tube. In this video, I'll be explaining you the simple applications of the refraction of light. If you haven't done this chapter before, then I have a video on the refraction at the plane surfaces. You can check that video and then enter into this one. Now first, I'm going to explain you what is apparent bending. Before explaining you apparent bending, I would like to tell you that you must have seen this phenomena in your daily life. Okay, अगर आप glass में पानी लेते हो, if you take a glass of water and if you place a pencil or a pen inside that glass of water, you will see that the pencil or the pen or whatever the object it is going to appear slightly bent. Okay, when you view it, then the pencil or the pen will be appearing to you slightly bent. Okay, so this is a consequence of the refraction and this is called apparent bending. Okay, so now I'll explain this apparent bending to you with the help of a ray diagram. Here you can see I've taken a stick. चलो इसको एक नाम दे देते हैं A B. ठीक है, तो ये एक stick है जो AB stick है. Now we are taking two rays from the end B. Always remember, if you want to make an image, you need to take a minimum of 2 rays. So I have taken here 2 rays. So this is one ray. It's going from a denser medium to a rarer medium. Okay, so whenever a ray of light goes from a denser medium to a rarer medium, what happens? It bends away from the normal. So I have drawn a normal at the point of the incidence of the ray at the two media, and now it is bending away from the normal. Same way for the second ray, it will bend away from the normal. Now you can see that these two rays are never going to meet because ये diverge कर रहा है. ठीक है? Now if you produce them backwards, you'll see that they are going to meet at a certain point. So this is B. This is the image of B, that is B dash. So if you are going to view it from here, you'll see this stick will appear to you like this, slightly bent. Okay, so this is one of the consequence of refraction. Okay, this is one of the consequence of refraction. There are many other consequences of refraction, like a print appears to be raised when a glass slab is placed over it. If you have a glass slab, for some people have it as a paper stopper, so if you have it, you can place it over your newspaper and you can see how the print is going to be appearing a little raised up to you. Okay, similarly, a tank appears shallow than its actual depth. Forget about a tank, you must have seen it in your everyday life, that if you see that a bucket of water which is kept in your washroom, if you view it, you'll see that the bottom of the bucket will appear to be raised up. Alright, same way, if a person's legs appear to be short when standing in a tank. ठीक है, आप लोगों ने स्विमिंग पूल में भी देखा होगा, कोई इंसान अगर स्विमिंग पूल में खड़ा होता है तो उसका लेग क्या होता है, उसका पैर क्या होता है, छोटा नजर आता है. Okay, so all these things are happening due to refraction of light. So these are the consequences of refraction of light. Also over here you can see I have made a diagram. क्या हो रहा है ये देखो, actually the fish is over here. This is the real depth of the fish. Okay, but if a person sees from outside, the person views the fish at this point. So this is the apparent depth. Actually this is the real depth. Actually the fish is at this point, but it appears to be at this point. So this is the apparent depth of the fish. Okay, and how is it happening? Very clearly, यहाँ से हम लोग को दो rays of light लेने हैं and it is going from a denser medium to a rarer medium. So it's going to bend away from the normal, and so if you produce the two refracted rays, it's going to meet at a point that is the image. Alright, same way you can see a person who is seeing a chest inside the river or a sea, the chest appears to him at this point and not at this. Actually chest kahan pe hai? At the bottom of the sea. Okay, but what it appears to him is the image of the chest appears to be at this particular point. Why is it so? Because अगर आप देखोगे यहाँ से हम लोग two rays of light ले रहे हैं, so it is moving away from the normal. So when you make the two rays produce backwards, you're going to see that it's going to meet over here. So the image of the chest will be formed at this point. So the real depth of the chest, is this, while the apparent depth, this is the real depth, and the apparent depth of the chest is this. Alright, so by now the concept of real depth and apparent depth must be clear to you, right? Now let us move ahead. Now you can see here I have explained with the help of ray diagram real depth and apparent depth. Why I have done so is, in your board examinations, in your class 10 board examinations, they usually give this ray diagram to show the real depth and the apparent depth, and also the relationship between the real depth, apparent depth, and the refractive index. Okay, so let us first see this ray diagram properly. The object, our object is this is our object. I'll call it O. Suppose this is O. Okay, now I've taken two rays because minimum we need to take two rays. तो यहाँ से मैंने एक रे लिया जो normally incident किया है इस interface पे. तो जो रे normally incident करता है वो कैसे पास होता है, एकदम straight चला जाता है, right? So the rays go straight without any refraction. Whereas I've taken the second ray at an angle of incidence, suppose I. All right. So now this ray, since it is going from a denser medium to a rarer medium, it bends away from the normal in this way. So this is my angle of refraction. Alright, is it clear? Now if I make this refracted ray produce backwards, it's going to meet at the point. So this is the image. Alright, is it clear to all of you? Okay, now coming to the relationship between real depth, apparent depth, and the refractive index of the medium. So let us suppose the refractive index of the medium be mu m. Okay, and now let us label this diagram. Suppose this is A dash. Okay, and let us suppose this one as A. Okay, now this is O, this is I, we have already mentioned. This is normal, so let it be n dash. Okay, let us name this ray also. Okay, so this is O, let us call it B. So this ray is OB, and now let us name this ray, so let us call it BC. Okay, so now we have names for each and everything over here. Now let us derive the relationship. Okay, now for students of ICSE board, the derivation of the relationship is not required. You only need to know the relationship between them for the numerical purpose. Alright, derivation is not there in your syllabus, but students of class 11 and 12, they have this derivation, and if you know the derivation, it becomes clear to you how you are getting the relationship. So just for your understanding, I'm showing you the derivation between these. All right, so first let us see what are the angles over here. Now you see here we have angle OBN dash, that is I. You can see that this is also I because this is this I and this I. Angle AOB and angle OBN dash is alternate angles, right? So angle A, sorry guys, angle AOB is equals to angle OBN dash, which is equals to I. And why is that so? Because they are alternate angles. Now similarly, you see IA dash and BN are parallel to parallel, and IC is a transversal line. So if we again take angle BIA dash, it is equal to angle CBN. I hope you're understanding, is equals to R. Okay, if you map it over here, you see BI, this one is I, BIA dash. So this one you can simply write BIA. This angle is equals to angle CBN, which is this. So this is R, this is also R, and why is it so? Because they are adjacent angles. We know this, right? So these are adjacent angles, okay, and this one alternate angles. All right, so they are also R. So we have got the expression of I, we have got I, we have got R. Now in a right angle triangle BAO, can you see this right angle triangle BAO? Okay, so in the right angle triangle BAO, what you can observe is, if you find out sin I, can you see I in BAO? So we take out sin I. We know sin I formula, perpendicular by hypotenuse, right? So the perpendicular is BA and the hypotenuse is IB. Okay, perpendicular is BA and, is it clear? OB, sorry. So BA by OB. Okay, BA, this one, by OB, hypotenuse. Okay, now same way, if you take, this is another triangle with R, we have to take two triangles, one with I and the other one with R. So this triangle, if you take triangle AIB, Okay, so what you can say is sin r, again perpendicular by hypotenuse, so perpendicular क्या है BA, hypotenuse क्या है IB. Alright, so we got the expression for sin I and sin R. We know that if we want to find the expression of refractive index, that is mu m, then how we are going to find? So first understand that the ray is going from denser to rarer. So first medium is this, second medium is this. So we always find the refractive index of second medium, that is air, with respect to the first medium, that is the medium, which is equal to sin I by sin R. Alright, now sin I, how much? What is sin I? Sin I is BA by OB. By sin R, if you do, it will come IB by BA. So BA and BA will get cancelled out. So you're left with refractive index of air with respect to the medium is equals to IB by OB. Is it clear to all of you? Now, IB by OB, can you write, because we want the refractive index of the medium. So can I write this one as refractive index of the medium with respect to air? So this becomes OB by IB. Okay, because it is the inverse. All right, now can we write IB as IA and OB as OA? Why? Because the point B is very close to the point A. See, ये तो हम लोग ले रहे हैं ना इतना बड़ा डिफरेंस, बट एक्चुअली रे तो ऐसे भी जा सकता है, रे ऐसे भी जा सकता है, कहीं से भी जा सकता है. तो हम लोग अज्यूम करें कि AB जो है they are very close to each other. So if AB is very close to each other, I can write in place of IB IA and OB OA. Okay, so if I'm writing it, sorry, just hold on for a second. So if I'm writing this one, I can write it like, taking it over here. So refractive index of the medium for OB OA and for IB IA. Alright, now what is OA? What is OA? Can you see over here? OA is the real depth. And what is IA? IA is the apparent depth. So what you're getting? Real depth by apparent depth. So the refractive index of a medium is equal to the real depth by the apparent depth. I hope everybody is clear with this thing. Okay, so let's move on to the next slide. Here you see, how are they related? Just now we have done real depth, refractive index of the medium is equals to real depth by the apparent depth. Now we can also calculate the shift. Now what is shift? So if you come back to this, you see this is the real depth and this is the apparent depth. The image has shifted itna. Okay, so this point is called the shift. We can denote it with the symbol X. Alright, so now shift, how can we calculate the shift? Real depth minus apparent depth. Now let the real depth be as it is. Now apparent depth, can I write apparent depth is equals to real depth by the refractive index of the medium, mu m. Okay, so I'm placing that value over here. I'm showing it to you guys. Okay, so real depth into minus the apparent depth. Apparent depth I'm writing as real depth by the refractive index of the medium. Alright, now you take the real depth common. So if you're taking, I'm writing in short, if you're taking the real depth common, this will become 1, this will become 1 by mu m. So this gives you your shift. Is it clear? So you guys will be getting straight numericals on the shift. Now let us see what are the factors on which the shift depends. So initially the first factor on which the shift depends is the refractive index of the medium. That is, higher the refractive index, more will be the shift. The more is the refractive index of the medium, the more will be the shift. Another factor on which it depends is the thickness of the denser medium. Suppose there's a glass block. So the thickness, it depends on the thickness of the glass block. You can also say it depends on the real depth, right? So this is the thickness of the glass block. And finally, color or wavelength of the incident light. The shift decreases with the increase in the wavelength of light used. If the wavelength of light increases, the shift is going to decrease. So therefore the shift for violet is more than the shift of the red light, because refractive index और wavelength जो होता है red का ज्यादा होता है, इसीलिए इसके लिए shift कम होता है. Understood? And violet का wavelength कम होता है, इसीलिए इसके लिए shift ज्यादा होता है. Okay? Now we have already done that when an object is in the denser medium and when it is viewed from the rarer medium, it appears to be shorter, it appears to be bent. Okay, now we'll see the vice versa. Okay, so we'll see that when an object is in the rarer medium and we are viewing it from the denser medium, so what is the effect of refraction at this point? So you see here I have made, this is the object in the rarer medium. Suppose this is glass, so this is the denser medium. Just hold on for a second. Okay, so this is the glass, so this is the denser medium. All right, and this is the rarer medium. An object is placed over here. Now if you are viewing it from here, the rays of light are coming from the object, so we need to take two rays of light. So one that is straight, it will go straight, because जो straight आता है normally incident करता है वो straight चला जाता है. And we'll take another ray. So यहाँ पे अगर हम लोग normal बनाएंगे, since it's going from rarer to denser, this ray is going to bend towards the normal. Now if we make these two rays produce backwards, they're going to meet at a farther distance. So the object is over here, but the eye is going to see the object at this point. So the object is going to appear taller. Okay, so there is a question based on this concept, and the question says that a fish is looking at a 1 meter high plant. So fish कहाँ से देखेगा? पानी के अंदर से. Okay, at the edge of a pond. Will the plant appear to the fish shorter or taller than its actual height? तो आंसर क्या होगा? Obviously taller, क्योंकि fish कहाँ से देख रहा है? Denser medium से. किसको देख रहा है? एक plant जो कि rarer medium में है. और अगर आपको ray diagram बनाने बोलेगा, you can make a ray diagram in support of your answer. You can make this ray diagram. All right. So is it clear to you? Now let us do few sums. So there's a question: a water pond appears to be 2.7 meter deep. So when it says appears to be, that means this is the apparent depth. All right, this is the apparent depth. So apparent depth, how much they are saying? 2.7 meter. All right, if the refractive index of water is 4/3, so refractive index of the medium is 4/3, find the actual depth of the pond. That means you want to find the real depth. All right, so how we are going to find the real depth? We have a straight formula. ठीक है, क्या है? Mu m is equals to real depth by apparent depth. Real depth हम लोग को find करना है. इसका मतलब real depth क्या हो जाएगा? Refractive index of the medium into the apparent depth. Now refractive index is how much? 4/3, and the apparent depth is 2.7. All right, so what are we going to do? You can cancel it out over here. So how you're going to cancel? We know 3 1, and that is becoming 0.9. All right, so answer will be 3.6 meter. Is it clear to all of you guys? Okay, now let us do another sum. A coin is placed at the bottom of a beaker. Suppose there's a coin, okay, and it is placed at the bottom of a beaker, okay, containing water, and refractive index of water is 4/3. So this beaker has water like this. All right, now the water is filled up to a depth of 12 centimeter. So the real depth of the coin is 12 centimeter. All right, by what height the coin appears to be raised when seen vertically up above? By what height? Okay, they're not asking about the apparent depth, they are asking about the shift. By what height the coin appears to be raised? कितना raised नजर आ रहा है, मतलब कितना shift हुआ है. ठीक है, so we know the formula of shift, right? We have done the formula of shift. And what is the formula of the shift? Shift is real depth, okay, into 1 minus 1 by refractive index of water. All right, so real depth kitna hai? 12. You can convert it to the SI unit. If you let it be in centimeter, your answer will come in centimeter. 1 by 4/3. So if you're going to calculate this, you're going to get 3 centimeter as the shift. All right, so do you want one more question? We can discuss one more question. Suppose there's a postage stamp which is kept below a rectangular glass block. Okay, a postage stamp which is kept below a rectangular glass block. A stamp kept below a rectangular glass block like this. Okay, now the refractive index of the glass block mu g is given to you, that is 1.5. When viewed from vertically above, you're viewing it from above, what happens, it appears to be raised by for 7 millimeter. That means they have given you the shift raised by, whenever this by term is there, so raised by 7.0 millimeter. All right, calculate the thickness. That means they are asking you the real depth. They are asking you the thickness. So this is the real depth of the stamp. All right, so we know what is the formula. We know that the shift is equals to real depth into 1 minus 1 by the refractive index of glass in this case. So you place the value of the shift. If you're going to place the value of shift as millimeter, you're going to get the answer in millimeter. If you're converting to centimeter, you'll get the answer in centimeter. If you convert it to meter, you'll get the answer in meter. I would suggest to get the answer in meter. You can leave it in centimeter as well, but don't leave it in millimeter. All right, so the real depth we would like to know, 1 minus 1 by 1.5. Now if you make this calculation, you'll get the refractive index, the real depth as 2.1 centimeter. Alright, so this is all for today guys. These were the application, the consequences of the refraction of light. In our next video, we'll be discussing about prisms, the refraction through prisms, the critical angle and the total internal reflection. Thank you.